In this video, we have a problem involving a demand equation. So here's what we have. Price P in dollars and the quantity X sold of a certain product obey the demand equation given by this. P is equal to negative 1/10 X plus 150. And the conditions are that X has to be greater than or equal to 0, less than or equal to 1500. So it has to be in that particular interval. So for part A, the revenue function R of X is given by the price of the item times the number of items, or the quantity. So R of X is equal to P times X. So for the first one, it's pretty straightforward. Take the revenue function and multiply this equation P by X. So just multiplying through, this will give me a minus 1/10. And then X times X there will give me an X squared. And then the 150 times X will give me 150X. So the revenue function that is given by R of X equal to negative 1/10 X squared plus 150X. Now for part B, what is the revenue if 100 units are sold? So this is just evaluating the revenue at 100. So you just simply substitute in for X here. So that'll be X squared, so that'll be 100 squared times the negative 1/10. So you can write that as a negative 0.1. And then 100 times 150. And you can use your calculator to do those calculations. This comes out to $14,000. So that's just evaluating the revenue function at X equal to 100. This one states, what quantity X maximizes revenue, and what is the maximum revenue? Let me write this again. The revenue function 0 to negative 1/10. I might write it as negative 0.1. Same thing. It's a negative 1/10. And then this is going to be X squared plus 150 X. And of course you should recognize this as a parabola, quadratic model represented by a quadratic function. And since the coefficient of the square term is negative, you'd expect the parabola to open this way. So when you're doing modeling like this, where the function is a parabola and it opens this way, opens down, the highest point is the vertex. So the maximum value can be found by simply locating the vertex. So there's several formulas or methods for finding the vertex of a parabola. I'm going to use this technique here. If the parabola with the equation with the function is in the form ax squared plus bx plus c. Okay, that's your general form here. So this is a, in this case, is negative 0.1, b is 150, and c is 0. So one way to find the vertex is use this formula here. If you have the formula in this particular formula we have, so it's negative b over 2a, where a is the coefficient of the square term, b is the coefficient of the x term. We just plug it in here. So this will be a negative, and then b is 150. I'll just put a 150 here. And that's divided by 2 times a, and a is a negative 0.1. So the negatives are going to cancel here. You have a negative here, and you get a negative up here. Those are going to cancel. So it's going to be 2 times 0.1. That's just going to be 0.2. So it's 150 divided by 0.2. Gives me 750. And that just tells me that the first component of this vertex is 750. It says what quantity X maximizes revenue. Well, the maximum value is going to occur at 750. So the answer to the first part is X equal to 750. So this would be maximum occurs at X equal to 750. And now it says, what is the maximum revenue? Well, they're just asking you for the graph looks this way, and the vertex is up here. HK, say it's your vertex. What is the maximum revenue? Well, maximum revenue is equal to, and then of course you just plug in 750 in for X into the revenue function. So this would just be R of 750. Just use your calculator for that. That's going to give you 56,250. Of course, this is dollars. Now, when I've done, you can do the same thing on your calculator if you have a graphing calculator. So let me just do this. I have the revenue function graphed or inputted here. Negative 0.1 instead of 1/10, I wrote it as a decimal, 0.1, negative 0.1, x squared plus 150. And then, of course, on these types of problems, you're going to have large values. So the window has to be large enough, otherwise the graph won't fit. So I have my x value, and the window for that one, I have it from 68 to 868 decimal, and then the maximum from 0 to 60. And the parabola looks something like this. I have it set to fit. So if I want to do it in the calculator, now I did it very easily by using this formula, minus b over 2a. But if you want to use it in the calculator, you go to second key and then calculate. And I want maximum, so I would hit 4. And then the left bound has to be to the left of that vertex. So make sure it's to the left, so I come over here, hit enter. And then the right bound, then you put it to the right of that. Make sure it's past that high point, hit enter. And then it wants a guess, you can ignore that, hit enter. And then here it is. Maximum occurs at x equal to 750.000. Okay, so it's actually 750 from that. You can tell that's 750. So the number of units that leads to a maximum revenue is 750. And the y tells you, or the second component tells you what the actual maximum revenue is. 56,250. Okay, so now we clear this. What price should the company charge to maximize revenue? What should the price be? Well, we know from the previous part there that 56,250 is the maximum revenue, and we want to find the price per item. And we know that the number of items that maximizes the revenue is 750. So we need 750 items to generate revenue, so what would be the price? Well, we just solve this for P. So divide through by 750, it cancels it over here, and then 750 over here on this side. So the price that needs to be charged in order to maximize the revenue, 56,250 divided by 750. 75. Thanks for watching. We'll see you next time.